Okay, today we're in chapter 3.7 and we're going to be doing an example where we're trying to calculate the total mass of a solid. The solid is going to be generated when we take a function, or in this case two functions, and we rotate them around the y-axis. We're given the density of this material, okay, as a function. Okay, so it's a function of x in this particular case, and we're asked to figure out what's the mass of the total solid that we get after rotating it. Okay, so in this case, we have the functions y equals 2 minus x and y equals radical x, and we're going to rotate them around the y-axis. So the first thing I want to do is I just want to come up with a quick sketch of what this is going to look like. And also behind the scenes, I actually checked and I found out where these two functions intersect each other, okay? And they intersect at x equals 1. You'll want to check that when you have two functions that are happening. So here's 2 minus x, and here's 1. It's going to look something like this, and this is radical x here. So this function here, this is what we're taking, and we're going to rotate this around the y-axis. So it's roughly speaking going to look like this, and we're going to rotate it around to get a solid. Now we're given the density, which is 200 times 1 plus x, and that's in kilograms per meters cubed. Okay, so now what we need to do is we have to take a look. Our volume, because I'm going around the y-axis, I'm going to use the shell method. Okay, so this is going to be 2 pi times r. Now my r, my radius, is whatever particular x value that I'm dealing with at the time. My height of the function is the upper function, 2 minus x, minus my lower function, and this is going to be dx. Okay, so this is my volume, and I would be integrating that. However, what we need to do to calculate the mass, okay, we're going to go again from 0 to 1. That's where these things intersect each other. Okay, we're going to take the volume times the density, okay, and that's going to give us our overall mass. Okay, so I'm going to put our density in, which is 200, 1 plus x, and I'm going to multiply that by the volume dx. Now I need to integrate that. I can multiply the 200 times the 2 pi, and I'm going to take that out. So I'm going to get 400 times pi. I'm still integrating from 0 to 1. Now I need to distribute. I've got 1 plus x times 2 minus x minus radical x. I need to multiply through all of these equations, and when I do that, I'm going to get an equation that looks like 2x minus x squared minus x to the 3 halves plus 2x squared, I know I can combine those, minus x cubed minus x to the 5 halves. And I'm going to integrate that with respect to x. When I integrate it using the power rule, I'm going to get 400 pi times x squared, so this is 2 times x squared divided by 2, minus x cubed over 3 minus, x to the 5 halves all over 5 halves. I have to increase this by 1. Okay, don't forget when we're doing the power rule. Plus, this is going to be 2/3 x cubed minus x to the 4th over 4 minus x to the 7 halves all over 7 halves. And I'm going to evaluate that from 0 to 1. When I plug it all in and add everything up, I'm going to get 3,340 times pi all over 21. And this is in kilograms. You can always check your units to make sure that things come out right.